We will be comparing AI coding approaches. One will be vibe coding and one will be spec-driven development. So here is a Spring Boot API which has order of $100. A single refund works in both. $30 are refunded and $70 are left. Now I send 2 refund requests at the same time of $60, and for vibe coded API both the requests passes. And the damage, the order was $100 and we have totally refunded $150. 30 from the first request and 120 from the next both attack. The vibe coded version does not see it as a problem. But when you run the same script for spec-driven development, the first request passes and the second request will fail. Damage done, nothing. $10 remaining. The API is working. The difference here is spec-driven development. We will see what it is, why GitHub and AWS are betting on it, and the full 14-phase workflow I built in Claude Code to do it strictly. Let's go. For the last 2 years, most of us learn to code with AI the same way. We will tell AI what we have to make. AI will make it for us. There will be something broken here. We will tell it what to do. AI will do it. There will be something broken here. We will tell AI what to do next. AI will do it. There will be something broken here too. And then this loop goes on. And at the end, we will find a stable app, hopefully. This is called as vibe coding. For prototypes, there is nothing wrong doing this. But for serious work, for something you have to ship, this is the pattern everyone will hit. Code that looks right but doesn't quite work. Architecture that drifts between sessions. 2 developers on the same code base producing 2 different code bases. GitHub put it something like this. We treat coding agents like search engines, when we should be treating them more like literal-minded pair programmers. They excel at pattern recognition but still need unambiguous instructions. So they are saying coding agents are bad at guessing intent from vague prompts. Spec-driven development inverts the relationship between specs and code. For decades, code was the source of truth. Specs were the scaffolding you threw away. Now the relationship has been inverted. Now spec is the source of truth and code is something generated from it via coding agent. And obviously it is possible now because we can generate executables from specs using LLMs. But SDD is not new. Quick history. CORBA's IDL files in the 90s pioneered spec generated code for interfaces. Protocol buffer carried that pattern forward in 2001. Test-driven development established write the contract first. Behavior-driven development in 2006 made specs readable in plain English. SDD takes those ideas and applies them to entire features, scaled up by LLM. One researcher has put it bluntly, SDD is not a revolution. It is just BDD with branding. He is mostly right. The branding matters because it reminds us that specs should be authoritative, not advisory. There are 2 tools I want to talk about. First is GitHub Spec Kit. GitHub Spec Kit have / commands which will be installed in your coding agent, and it is open source. The second is AWS Kiro, which is built on the same open source repo on which VS Code is built on. A fully agentic IDE like VS Code with spec-driven development baked in. You can try it. But why did I build my own workflow? Both the approaches which are already there, they are good. If you want to try spec-driven development today, install one of them and links are in the description. But I wanted to build my own. Tighter gates, my own templates, my own agents and my own workflow. 14 phases, 11 Claude subagents and 5 human gates. One orchestrator that takes care of everything and its role is to invoke the right subagent. Let me walk you through the whole workflow. Here is the SDD orchestrator. This guy is the brain of my whole workflow. It will decide what will happen next. This will start from repo init, then it will fetch the issue. Once the issue is fetched from GitHub, it will create requirement clarification. It will ask me a lot of questions to clear the requirements. Once the requirements are cleared, it will use this requirement agent to create the requirement. Once they are ready, it will show me as an MD file to review. Once I have reviewed the requirements, it will start the design clarification phase. Once all the questions are answered by me and it has full idea of design, it will create a technical design using this technical design subagent. Once the technical design is ready, it will require approval from me, and once the approval is given to it, it will start with the task planner subagent. It will divide the whole work in small tasks. Once the tasks are finalized, it will start with TDD implementation. Once the TDD implementation is done, it will automatically start the review agent. Once the review agent is done, it will give me the review findings. Here is the point where we will review the whole code. Even if we gave it proper requirements and design, there are chances that there are mistakes here and you don't ship anything which is not reviewed. Once you have reviewed the code and you have accepted whatever findings it has given you, you have added your findings, it will start this review resolution agent. It will resolve all the findings, and this is loop. It will again start the review agent. It will do the human triage again. It will resolve if if there is any review finding. Once we are fully satisfied with the PR, it will ask for a final approval. Here the review is optional, but if you want to review again, this is the step. Once the final approval is given, a PR agent will ask you if it can raise a PR or it can only commit or it can push. It will take care of it. Here is the part that makes this workflow different. Clarification loops. Requirement clarifications, design clarifications, they are the best part of this workflow. Requirement clarification will ask who are the users, what are the edge cases, what is the expected outcome. Design clarification will ask you technical question, what is the architecture, what is the data model, migration, security. Most of the workflows will skip this. Skipping them is where the worst rework comes from. The first time you use SSD, you will understand that you will catch most of the bugs in this clarification phases that you will not be able to catch in your wipe coding workflow. These are the unambiguous instructions for your LLM. These are the few example templates which will be produced when you run this workflow. The most important files are requirements.md, where your all requirements will be stored for you to approve. Second is technicaldesign.md, your architecture, file changes, API changes, validation rules, security, migration, rollback plan, everything will be stored here. And the task.md. Here all the tasks which will be created by it will be stored. And the main part, our workflow is not skipping any approvals. Once the requirement is approved, then only we will move to technical design. Once the technical design is approved, then only we will move to the implementation. Implementation will run task by task. Test first, confirm it is failing for the right reason. Write a minimum code to make it green. Then confirm it passes. Then we will refactor and log every step in traceability.md. A task can't be tested first. The subagent will record an explicit exception with justification, risk, compensating verification before any of the production code changes. No silent skip. Then the review subagents reviews the dev. It will find the findings which are numbered, and you can add your own findings because you are also doing a code review that time. Then we will have a final summary.md file where we will record everything. Here is my Claude Code instance, and let's start with the demo. I will use my SDD orchestrator agent and will ask it to analyze the repo. You can do it by added symbol here in Claude Code. You can select your agent and I will say analyze this repo. While it is analyzing the repo, we can go to the repo and I will show you what we are doing. This is the repo we will be using. It is just for the demo. This is the issue I created. This is the feature what we will be building. The feature will be adding a partial refund endpoint. There is already a refund endpoint. Customer should be able to request a partial refund on a completed order. We need a new endpoint to take order ID and refund amount and call the payment provider, record the refund and update the order status. This is the same key feature I built using wipe coding approach, and because it didn't ask any clarification questions, it did everything on its own, and the code it generated you saw was not good. It is done analyzing the repo. Let's look at this project.md file first. This project.md file consists of all the data about this repo so that my agent don't have to read the repo again and again, and it can just go through this project.md file. Will be able to get any information it needs regarding the project. You should also have some init feature in your own repo so that your agent don't have to read the repo again and again. It will save a lot of tokens for you. I will recommend you guys to run this init part as frequent as possible so that it will update this project.md file and your coding agent will have the current view of your project. Let's start working on the issue we have. I will again select my agent and I will ask it to start working on issue number 1. It is asking me some clarification questions here. I will be putting these all on notepad with question and answers. You can see them in one view. These are the answers I will be giving it. You can pause and read through all of them, but I would to take your focus on this question it asks, concurrency, and I answered it. The safety part I added my own because this is an ideal scenario when we are building partial refund features like this, that multiple concurrent requests can come together. If we don't take care of it, overall order value will be negative. Let me copy paste this to my agent and it will continue with the process. As you can see, it has created a requirement.md file for me after asking me clarification questions about the requirements. I will recommend to fully read this requirement.md file because with AI there are a lot of chances that the requirements are wrong even after the clarification. If we have anything wrong after the clarifications, I can add it here and it will again generate the requirement.md file till I am satisfied. For the demo, I won't be reading it, but I will show you the requirement file it has created. Under the docs folder in specs folder, it has created issue number 1 and it has generated requirements.md file. You can can also say requirement-clarification file, which it has stored here. These are all the requirements we have given it and it has understood. If it was a real repo and I have to ship this code, I will read the whole requirements.md, and if there is anything wrong with it, I will ask the agent to resolve it. Once I am fully satisfied with the requirements file, then only I will move to the next step. For now, I will approve it. Let's tell it that it is approved so that it can continue with the process. You can see it has moved to technical design phase. It will either come up with some clarification questions, or if it is able to fully understand everything, it will directly generate a design file for me. So it didn't ask me any clarification questions here. It has directly created a design MD file because it didn't had any questions. It has everything cleared. So it created a design MD file for me. Can review this. If I have any changes in that design.md file, I can add those changes here and it will update this design.md file for me to review again till I am satisfied with the design. I will recommend to read everything in design.md file, because if it asks you any clarification, even after this there are chances that it is hallucinating and it will create any design. If you see this approach, you are not just writing a prompt. Here, when you start building a feature, you should know in your head that how will you build the feature. That's how we do coding previously, right? We get a feature, we create a design, we put it anywhere, either in Obsidian, Notion, anywhere, either in your notepad or your notebook, anywhere. You draw a full picture of the design. You know in your head what code will you add, what design pattern you use, and everything regarding that feature. Once you know everything, you will start coding. That is what we are doing with the AI agent here. We are clarifying everything to this AI agent. Here we are not just audience, we are driving it as a pair programmer. I should know how this feature should be built, what changes should be done, what are the requirements, what will be the design changes in the code. Once it created the design, if I don't like the design pattern it is using, if I have some other idea, I can discuss with my agent here, right? For now, I will approve the design. You can see my agent has moved to task breakdown phase. It will break down the tasks, then it will start TDD on every task, and then it will start a review agent and it will be back with all the review findings. For the implementation it did. As it was taking a lot of time, I went outside and came back. Let me resume. You can see it is saying that we are at human review triage phase. These are all the review findings it gave us. All are low or info severity, and here is the phase where I review the full code. So from here I can click on any of the file and I can see the git diff. I review all the code changed by my coding agent. This is very necessary. If you are shipping the code, you should review all the code, because even after all this, it might have done some mistake here and there. They are not at all reliable. You should review everything. Also, it has generated a review finding file where you can find all the review findings. It has also ran all the test cases. All the test cases are green now. There are multiple options. Either I can accept or reject, or in my code review, if I find anything which it didn't catch, I will add it as my custom finding here, and it will add it to this MD file, so it will take care at the time of resolution. This is just for the demo, so I will accept all. Here you can see it is continuing with the orchestrator with the triage decision I made, and I have accepted all the 4 findings. As you can see, it has come to the human resolution approval stage here. Once it is done with all the resolution, you can check the diff of everything it did. If you have time, I will recommend to review all the code again, because mistakes should be minimal in the code you ship. You are the developer. You should not act as an audience here. You should act as someone who owns this product and is creating this. It is asking me, do I approve this resolved changes? For the demo, I will say yes, I am approving this, and it will move to the final summary stage. This is the final summary stage of our workflow. Here it has updated my final summary.md file on disk, and it is asking me to either commit, raise a PR, commit and raise a PR, and I can either stop here. Let us go and see this final summary.md file first. Here is the final summary.md file it created, and you can see it has updated each and everything, what it built, what are the file changes, the requirement coverage, review finding, test results, outstanding items, decision gates. So for the demo, let's commit it, and can say commit. As you can see, it is done with the commits, and here is the end of our demo. Let's move on to the trade-offs and let's wrap this up. The honest part, this whole workflow has overhead. You will spend a lot of time upfront in requirement clarification and your design, which you don't spend in vibe coding. So let's look at when to use which. You can use vibe coding when you are creating prototype, you are exploring some unknowns and trying different things in your hackathon projects, in your personal tools. You can use vibe coding here, but don't use vibe coding in production system. Use spec-driven development. It will give you a more reliable code. You should use spec-driven development in the code that handles money for the long-lived code and for team code bases. The time you will spend upfront in spec-driven development will save multiple reworks, debugging, and rebuild. From my point of view, takeaway from this workflow is your test stop being an afterthought. The design doc you have created is not a fictional, and the next person who is reading this code, including the future you, has the requirements, the design, the traceability, and I can say the full history sitting right here in your repo. So Spec Kit is good when you want to get started fast. Kiro is good if you want IDE experience, but if you are a developer, I assume you will have your own custom workflow. Even in your career, you will have different workflows you will try to find which better suits your style. Instead of using them, you can create your own workflows which will complement you better. Please leave a comment on this video what you think about this workflow and any improvements I can make. I am continuously improving this workflow and I read all the comments. Like and subscribe to the channel. It helps the channel a lot, and see you in the next video.